So question 8 says, solve the following logarithmic equation, verify your results using a graphing utility. So again, they ask us, what is the exact solution? Select the correct choice below. So again, they want us to find the exact answer. So we really need to do this by hand. So one of the first things we pick up on is domain. So remember, when you take the log, what you're taking the log of has to be greater than 0. So that means that x minus 2. So x minus 2. Let's get this thing to write for us. Okay. Let's see if I make this go away. Where'd my question go? All right. So this x minus 2 has to be greater than 0. The x plus 11 has to be greater than 0. The x minus 5 has to be greater than 0. And the x plus 4 has to be greater than 0. So we have to be greater than 2. We got to be greater than a negative 11. We have to be greater than 5. And we have to be greater than negative 4. So if I look at this on a number line perspective, so negative 11 would be the furthest one over. We have a negative 4, and then we have a 2, and we have a 5. So you got to be greater than a negative 11, and you got to be greater than negative 4, and you got to be greater than 2, and you got to be greater than 5. So the one that makes these all true would be greater than 5. So off the bat, our domain has to be greater than 5. If it's not greater than 5, then we have to throw it out. So notice that, they don't really give us an actual base in this problem. So that's going to be interesting as we move forward. Why do they just gave us a variable for a base? So we'll approach that here in a little bit. So one of the things we want to do once we determine the domain is we want to use the property of logarithms to rewrite each side as a single logarithm. So we have this log of x minus 2 minus the log of x plus 11. So let me pause this video for a second and rewrite this problem here. So I'll rewrite the problem here. We have the log of x minus 2 base a minus the log of x plus 11 base a is equal to the log of x minus 5 base a minus the log of x plus 4 base a. So when I want to rewrite these as single logarithms, since this is subtraction, this becomes a quotient. So this turns into the log of, and the x minus 2 becomes the numerator over the x plus 11. This is going to be a base a. And that's going to equal then, and since this is subtraction, this is also going to be a quotient. So this is going to be the log of x minus 5. That's going to be the numerator, and the x plus 4 is going to be the denominator. And this is going to be base a. So I wrote those as a quotient. Now, for this to be equal, notice that since we're using the same base, we got to be taking the log of the same thing for this to hold true. So what has to happen here then is what we're taking the log of has to be equal to each other. So this x minus 2 over this x plus 11 has to equal this x minus 5 over this x plus 4. So what we have is a proportion, and with proportion math, the cross products must be equal. So this allows us to kind of cross multiply. So we now have this x plus 4 times this x minus 2. That has to equal this x plus 11 times this x minus 5. So if we multiply this all out, this is going to give us this x squared. And then we're going to have a negative 2x and a positive 4x. So negative 2x and a positive 4x is going to be a 2x. So plus 2x. And then the last terms, 4 times negative 2 would be minus 8. So I have this x squared. Then the outer terms gives me that negative 5x. The inner terms gives me this 11x. So negative 5x and 11x would be 6x. And then 11 times negative 5 would be negative 55. So if we set this equal to 0, notice that the x squareds would zero out. So if I bring the linear terms, I would rather bring the linear term, the 2x, over here. So if I do subtraction 2x, that'll keep me with a positive coefficient for the x's. So that's going to give me a 4x. I'd rather have the constants on the other side, so I want to add a 55 to both sides to get the constant on the other side. So again, the x squared is just zeroed out altogether. So negative 8 plus this 55 is what I'm looking at. Y equals, clear that off. Quit that, clear that. So really what I need to do right now is negative 8 plus 55. That should be what, 47? So 47. Oops, let's do that back to green. So essentially what we have then is 4x equals 47. If I divide both sides by 4, I get 47/4 as the exact answer. So if we come back up here, we would say the solution would be 47/4 because it does say type an exact answer in. Usually they want fractions there, but this fraction actually would have it would actually be an exact decimal too. So 11.75, it should also accept 11.75 since it does not say anything about fractions here. Now, if I want to graph this, what I want to do is say y equals, and I'm going to have the log of x plus 2 base a minus the log of x plus 11. Let me give myself some room here. I'm going to run out of room here. That's part of the challenge is trying to visualize where do I want to write stuff at. I still struggle with that. So I'm going to put this underneath here. So y equals, I'm going to keep this on this side, the log of x minus 2 base a minus the log of x plus 11 base a. And I'm going to bring this over to the other side, so it's going to become a negative one. So minus then the log of x minus 5 base a. In this negative log of a x plus 4 base a, it's going to become a positive when I bring it over. So a positive log of x plus 4 base a. So this equation, it shouldn't really matter what the base is. So if I'm going to graph this, I'm just going to use the base 10 logarithm. I'm just going to use the log logarithm because it didn't, again, basically what this is saying is it doesn't matter what the base is in this situation. So I'm going to hit then, if I'm going to graph it, I'm going to type in the log of x minus 2. And then I'm going to subtract then the log of x plus 11. And then I brought this piece over, so it's going to be now a negative. So minus, I got too many parentheses here. So minus then the log of x minus 5. That looks okay. And then plus the log of x plus 4. Oops, don't need that extra parenthesis there. So that looks okay. So if I graph this, notice that we're thinking around 11.25. So I may want to change my window, hit my window, and I may want to change, instead of saying 10, I may want to say 20. And let's just go by twos. If I graph again, so I have like 2, 4, 6, 8, 10, 12. So the 0 is going to occur somewhere between these two values. So if I hit second calculate to my left bound, I'm left, hit enter. And then let's just go out here a little bit. So I'm thinking out there somewhere, hit enter. If I enter again, hopefully that takes me to the middle here. That gives me 11.75. Is that what I said the answer was? Was 11.75? So if it second quit. Yeah, 11.75 is what I said the answer was. So it does verify on the graphing calculator of 11.75. The other thing is, are we greater than 5? Yes, we are. So we can keep that answer. So don't forget that we had to be greater than 5 and we were. So 11.75 does meet that condition.